Since it's raining today in California and the weather's not very good, we're going to stay inside for this segment. We're in the stationary engine part of my garage. This is a Stirling hot air engine. These were used to pump water. Got this out of Teddy Roosevelt's house. Interesting story, but we're not going to deal with that one today. This is a steam engine out of a tugboat from about 1900. We haven't got this running yet, but we'll hook it up. If you've been on this website before, you've seen our 1866 Wright steam engine, designed and built when Lincoln was president. But we're not going to focus on that one either today because, well, we did a piece on this one. You can go to the website and check that one out. I'm going to go to the oldest engine of my collection, this one over here. This thing was designed and built in 1832. 1832, think how long ago that was. This ran a color and dye factory in England. Don't have a lot of history on it. I know Henry Ford bought it in the mid-20s for his museum. It was an antique then. It got sold off. It went to a number of owners. I got it. We restored it. And it's running for probably the first time in, I would guess, 70 or 80 years anyway. Quite a fascinating piece of equipment. You notice how wedges hold everything together? You see, you set everything up and then you tap those in where you want them and they hold it firm, or just firm enough to hold it and not fall out but still be able to move. The whole thing is put together with these. See, there's a tension on them here so they can't back out. That's kind of cool. Well, here, let's fire it up. This is about the speed it would run back in the day. You know, it's interesting. People kind of get the misconception that machine shops back in the late 1800s were noisy places. They weren't. Steam was very quiet. I mean, you hear how much noise this thing is making, hardly any at all, just a little bit of creaking. And once it warms up and everything gets really hot, it's almost completely silent. What you're hearing right now is mostly metal expanding and contracting until everything gets warm. But this would run all day long. This engine ran, I'm told, for almost 100 years before Henry Ford bought it. So, no, he bought it in the 20s. All right, 80 years, about 80 years, yeah. Ignore the wizard behind the curtain. That's Jim back there. He's the Wizard of Oz. He's running. The throttle valve is really just a steam valve. You open or close it. I mean, you see how slowly you can run these. You can run these literally down to about 5 RPM. But they like to run about maybe 120 RPM, something like that. The interesting thing about it is it was built in 1832, built in England, but we don't know who built it because they didn't put their name on it. But they did a beautiful job. Your piston is in here. So this will come and, hit you in there. Notice the Napoleonic, or the Greek columns rather. These were really sort of the space shuttles of their day, and they wanted to be as intricate and beautiful as possible, because they wanted to show off the technology of the day. You know, when you look at modern machinery, it's very efficient, but it's not pretty. You know, and this is really, I think, a beautiful piece of early 18th century artwork. It's what you call your walking beam up here. These are lubrication points up here. You fill these with oil and those drip down. This is your lubricator. This fills with oil and sends oil into the cylinder. Water, obviously not a lubricant. So what that does, it puts a little dollop of steam oil into the piston on every stroke. This is what people did before television. You'd sit down and you just watch your steam engine run all day, and it's a fascinating thing to look at. This is your governor. What this does is, as the centrifugal weight throws the balls out, that controls your throttle so you don't overrev the motor. This is where the famous expression balls out comes from. Balls to the wall, that's another whole different one. But balls out comes from steam engines. We had to make a couple of new pieces. This was cracked, so we took the old piece off, designed it on our Fadal CNC machine, and made a new one out of brass. Here, take a look. What Bernard is doing is redesigning the part, or I guess scanning it on the computer so we can make another one. Is that correct?
Well, yeah, what we did here is start out with some simple geometry of the top view and an end view of the part.
Okay, I hear simple geometry, and I'm out of here. See, the great advantage of this is almost any mechanical piece you have for any kind of vehicle, or just about any kind of engine, you can redesign or make a brand new one using this Gibbs program. It's pretty amazing. It's something that would take a machinist weeks to do, you can actually do fairly quickly here.
Yeah, the neat part is you can design it on the computer screen and attach pieces together. See, we now have the back section of it and the front section of it. There's a hole down through the center of it. We can also rotate this around so we can get different views of it. So you see the hole that goes down through it, where it's going to sit on its shaft. Got a front view, side view, top view. From here we go to the next step, which is to generate a G-code that the machine can read, and then we can do the machining on the Fadal.
Let's plug it in and make the part.
And I think we're ready to go here. We got this is our program here. We'll see what happens. So what we're going to do first, we're going to cut the top down before we start making a real nice pattern for it, so it'll save some time.
Now you notice the older the machine, the bigger the balls. That's kind of the way life is, I guess. But look at all the way this goes. There's your pump down there. That's your water pump down there in the hole. Don't forget, this is before the days of standardized threads. There was no standard thread, standard screw. Everything was made for that particular machine. You always want to make sure you've got plenty of oil. There are all sorts of little places you need to constantly keep monitoring. Look at these all hand-cut gears in here. Look at this, beautifully done. Not just they were designing this thing today. Hey, don't stand near that. Hey, don't look at that. Hey, keep 50 feet away. No, not back in those days. Guys would reach in, the ball would hit you in the head, and then this would come down and crush your skull. And no, that's too bad. Yeah, tough break. Yeah. Insurance, get out of here. It's your own fault. It's amazing to look at now. I can't imagine what it was like in 1832. England really ruled the world. England controlled steam power. James Watt, of course, the genius of steam, he really designed everything. And the English guarded this technology the way we would guard our defense systems today, because those who ruled steam ruled the world. Your factories, your ships, everything. Anyway, I hope you enjoyed looking at something different. As soon as the rain stops, we'll take some more cars and motorcycles out and do some burnouts. But right now, I'm just going to spend a quiet afternoon looking at my steam engines.